This is the first of what I expect will be many short lectures dealing with the material in Math 231. Okay, so the first thing that you'll have to do, a lot more of than probably what you're used to doing, is reading outside of class. So before you actually listen to this video, it's probably best if you first read chapter 2.5.1 in the text, which is on variation of parameters, which is basically going after the particular solution. Now, we already know that the solution to the ODE is the sum of the homogeneous and particular. And we also know how to get the homogeneous solution. We just take the exponential of the antiderivative of the little a of t. For the particular solution, we have what is known as the variation of parameters formula, which is given down here. You can see it depends on the function of f of t in the integrand of the big integral. I won't go through the derivation here. It's talked about a bit in the book. And so what I want to do is just go through a couple of examples where we solve the full problem with an initial condition. Okay, so the first problem I want to look at is x prime equals minus 2x plus 4e to the 2t with x of 0 equals minus 3. We worry about the initial condition after we get the general solution. So first, we need the homogeneous solution. Okay, to get that, we know how to get it. We do the exponential of the antiderivative of the a, which in this case is minus 2. And so this is then going to be equal to c1 e to the minus 2t. Okay, for the particular solution, we use the variation of parameters formula. You see the pieces. The first piece is e to the antiderivative of the little a, which is e to the minus 2t. Then we're going to take a big integral, and so now we have e to the minus antiderivative. A minus minus 2 gives a plus 2, so we give an e to the 2t. The f of t is 4e to the 2t. And so then we do the anti-differentiation. We get e to the minus 2t, antiderivative 4e to the 4t. And so this, after we do a little bit of the algebra, becomes e to the 2t. So now the general solution then is the sum of the two pieces. So it's given by c1 e to the minus 2t, that's the homogeneous piece, plus e to the 2t, that's the particular piece. And note that the particular piece does not have an arbitrary constant in front of it. Only the homogeneous piece will have an arbitrary constant. Now we go after the initial condition. And so we have x of 0 equals minus 3. So that's equal to c1, because e to the 0 is 0, plus 1. And we go ahead and solve that. And we get c1 is equal to minus 4. So we finish then with the solution. It's given by x of t is minus 4 e to the minus 2t plus e to the 2t. Okay, that seemed fairly straightforward. As long as we can do the antiderivatives, we're in good shape. Okay, so let's go to the next question. We have a different problem now. Different a of t, different constant. So in this case, we have a of t is 1 over 8 plus t. So the antiderivative is equal to the natural log of 8 plus t. So e to the natural log of 8 plus t is 8 plus t. So the homogeneous solution then is C1 times 8 plus t. Now for the particular solution, we use our variation of parameters formula again, which says that the particular is the homogeneous piece. Now the antiderivative of 1 over the homogeneous, because remember e to the minus x is 1 over e to the x, times the forcing function, which is just minus 1/8. And so then this is equal to minus 1/8 times 8 plus t times the natural log of 8 plus t. So that gives us then our general solution. It's the sum of the two pieces, homogeneous plus particular. So it's C1 times 8 plus t minus 1/8, 8 plus t, natural log of 8 plus t. Now we go to the initial condition. We're told 9 is x of 0. And so that's 8c1. 1/8 times 8 is just 1, so it's minus natural log of 8. And so then C1 is 1/8 9 plus natural log of 8. So the solution in the end to the initial value problem is then finally going to be x of t is equal to 1/8 9 plus the natural log of 8 times 8 plus t minus 1/8 8 plus t natural log of 8 plus t. Okay, so in the end, in both problems, I'm simply using the formula for a variation of parameters. And of course, you'll have to memorize it for an exam. And I, of course, have done this so many times, I've memorized it at this point. But it's not hard to memorize. And the thing to remember when doing this is that when you look at this term right here, e to the minus at dt, you just have to remember that that is equal to, or the same thing as 1 divided by e to the a of t dt. Because again, e to the minus x is e to the x. Okay.